for coming to hear me talk about integrating disciplines for NRM outcomes. So I've got the fun task of keeping you entertained for the next 10 minutes when there's an hour to go to drinks. So bear with me, and I'll be talking about modelling, which we know will keep everyone wide awake. So sometimes in natural resource management, we do actually have available to us a wide variety of data. We might have some ecological conceptual models of the issue that we're looking at. We might have some groundwater borehole data. We might have some hydraulic or some hydrological data available to us. We might have some species distributions. We might have some soil type data. And a shameless plug here, a lot of this is available in EnviroData or WaterConnect. Now, everyone here intuitively in the room knows that all these different factors interact, and they interact with each other. So the question here, or the problem here, is how do we best take advantage of the data that we have available to us? So this was the project, or the problem, depending which way you look at it, that was given to me. So on the South Australian River Murray Floodplain Integrated Infrastructure Program, SARFIP, we have available on the Pike and Cataraqui floodplains. We do have some, I'm going to try the pointer here, awesome groundwater modelling, we have some awesome hydraulic modelling, we have some ecological conceptual models, we have soil data, we have vegetation data. So I sat there and went, okay, well, what modelling platform am I going to use to try and get all these things together? So cutting straight to the chase, it was, yay, BBNs to the rescue. So I hope everyone is waking up on a beautiful pop culture reference. So just quickly though, why Bayesian belief networks or why BBNs? I'm going to quickly go through 3 key attributes of why I chose these. They do take a variety of inputs, so variety of quantitative and qualitative information and data. They are transparent, and they are good for visual communication. So I will elaborate on these further now. For those who are familiar with BBNs, I apologise now because the rest of the talk you may fall asleep unless I do a cartwheel or something. But if you were like me a year ago and you thought, oh, BaseNets, I've heard of them somewhere, but I don't really know what they are. So what is a BaseNet? In essence, and a BaseNet statistician probably kill me for this, it's kind of like a box and arrow kind of diagram, a conceptual model with probabilities added in. So I'm going to use an example here to take you through a BaseNet, and it should be one everyone's familiar with. It's the heads and tails game. So if you're at a quiz night and the MC's tossing 2 coins, you have to guess whether you've got heads, 2 tails, one, you know what I mean. Okay, so what we have here is the box. This is called a node, and I'm saying it's called the first coin, which is toss 1. And we have on the left-hand side the outcome of toss 1, or what the states of the toss 1 can be, and it can be a heads and tails. Now everyone knows here, unless it's some sort of magician weighted coin, we've got a 50% chance, I'm not very good at this laser thing, 50% chance of it being heads, 50% chance of it being tails. Then we've got the second toss 2, it's the same, again, unless it's a weighted coin, you've got 50% chance of heads, 50% chance of tails. Now these in BaseNets are what we call the parent node. They influence what's called the child node, which here, as I'm putting, is the outcomes. Now the outcomes are, it's either going to be 2 heads, 2 tails, heads and tails. Now everyone here will know your best chance really, 50% chance is to put 1 hand on your head, 1 hand on your bum. If you're a bit riskier, you'll do the 25% of heads and tails. Then, however, if you're at the quiz night, you're checking your phone for Googling the answer of something you shouldn't be doing, you might have heard the MC call out that it's already a heads, so we know it's 100% probability that it's a heads, which means this changed the outcome box here into it can only be a heads or heads and tails, and if you're still Googling away, then you might hear the MC call out that it's a 2 heads or 102 heads. So I hope everyone's sort of with me up to this point in time. Now clearly this is quite a simple example of 2 nodes and 1 child node, and it's not directly applicable to NRM unless you're in an NRM fundraising quiz night, which I hope everyone at least goes to 1 a year. This is what a BaseNet can look like. This is a BaseNet for population health of fish to do with filling a wetland. It's developed by the Murray-Darling Freshwater Research Centre, and it's freely available on their website. Some of the inputs into this BaseNet are vegetation cover, water depth, area of the wetland, season that the wetland filling happens, and your method of filling. So this brings me to one of my first key points about Bayes nets, and that is that they do take this variable inputs. So a variety of inputs can be put into it. But you might now all be thinking, well, I'll get this structure, but what's actually driving the model behind there? So if we go back to my beautiful heads and tails example, the main thing driving the model behind this is something that you might have heard referred to as the conditional probability table, or, casual talk, the old CPT. And this is what a CPT looks like. Here we have, on the left-hand side, you basically have all the different combinations of the different states of the parent node, so heads, 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 tails, tails, heads. And on the right-hand side, the probability of those states affecting the outcome of the child node. So this one's quite simple here. If it's a heads and heads, well, there's a 100% probability that it's a heads and heads outcome of the child node. But you can, if it's some sort of magician perhaps doing the coin toss, those can change. So you can have like a 70, 20, 10, I think that equals 100, doesn't it? Yep. So that's the basic of the CPT. So one of the key points here are these CPTs are transparent. I can go into anyone's model who's built a BBN and have a look at it to see what's driving it. So if you are building a model and you don't know who's going to be using it and you don't know how long it's going to be used for, anyone else can pick up this BBN. The second key point about this is it does take a variety of quantitative and qualitative information. So obviously from our example here, we know it's 100%, and if you've got a beautiful mathematical model sitting behind it, you can fill it with some quantitative model that sits behind it. But often in natural resource management, we don't have that. We have to rely on experts. And so one of the beauties and why often Bayes nets are used is getting this expert knowledge and populating this table. Now, this is obviously a very big benefit and attribute of the Bayes net or the CPT, but it is also, for my next really bad pop culture reference, kind of like Batman talking to Superman. You're asking someone with all this theoretical knowledge to then do a probability distribution table. So it does need to be really carefully considered, your approach and how you're using it. So I will give a short example of how you approach setting up a Bayes net. So you can all go away and set up Bayes nets using the example that I'm working on the Pike and Kataroko floodplains. So we decided to first build a Bayes net looking at the response of River Red Gum, the future condition of River Red Gum on these floodplains. So first of all, we look at a conceptual model. Conceptually, most people here look at the River Red Gum and we know that the future conditions what we're interested in, and that's going to be influenced by current condition and total soil water potential, which in turn is influenced by your matrix potential and your osmotic potential, which in turn is influenced by your frequency and duration of inundation, your depth to groundwater, your soil type, your groundwater salinity, your soil salinity. This is the Bayes net I've produced. I'm not going to go in detail to this because that'll be a whole nother talk. What I do really want to show you is that the structure of it is based on the conceptual model. So we have a future condition, we have a current condition, we have a total soil water potential indicator, we include inputs such as depth to groundwater, groundwater salinity, soil type, and frequency and duration of inundation. So this brings me to that last key point, which was it is good for visual communication. I think most people can sort of see that what influences what in the model straight away. And if you wanted to, sit down with a bottle of wine, I could really take you through the details of this awesome, awesome model. Of course, no model, however, isn't without its relative weaknesses compared to other models. So the kryptonite, hope everyone gets that reference, thank you. The kryptonite too, I guess, less, weaknesses of this model compared to other modelling techniques is incorporation of a temporal scale. It doesn't easily incorporate time series data, so you need careful consideration on how you're doing that, especially compared to some other modelling techniques. And there's also, and this is often mentioned in the literature, this issue of node discretisation. And by that, I mean if we have this node called end condition, I've said here it's got 3 states of healthy, unhealthy and dead. Now I could have used 5 states. I could have had an almost dead but might come back to life. So why have I chosen these 3 states and what do they mean? And then similarly, if you've got a sort of continuous data set, how many different states do you break it up into? And where do you break it up? What are the meanings behind that? Because the different number of states and how you divide it can actually have big influences on the final outcomes. So, to summarise, Bayes nets are really good for taking a variety of quantitative and qualitative information and data and variable inputs. They are transparent, they can be used by other people, and you can see what people have said about stuff. They are good for visual communication and potentially even talking to the community if you can take it down some other lists. I know it's against all presentation rules to mention a new thing in the last slide, but I do want to put a plug in here that BBNs can be made spatially explicit, so through a GIS linkage. It is probably another talk in there, but has benefits over many other models which can't be made spatially explicit. Something that does need careful consideration is how you develop the CPTs, especially if you're using expert elicitation. And finally, the relative compared to other modelling methods, you do need careful consideration what you're doing with the temporal scale, particularly if you're using time series data and you want to incorporate that, and how you discretise the nodes. And I think that's it. I think that was beautifully timed.